a particular use case, which is modernization. Could be small modernization, just adding a new feature to a core system that is very complex, and up to very large, complex migrations, refactor, reimagining your applications, and so on. So, background about modernization. Um, we work with a lot of organizations, particularly that have core applications that are critical to the business, ones that are, are in charge of high stakes operational aspects of the business, and usually ones that are also in relatively regulated industries. So they need predictable, repeatable processes. They need the application to run smoothly with not a lot of errors. And for that reason, they chose particular technologies. Let's mention mainframe specifically as an example, that are very stable. And these applications serve them well, sometimes for decades. Um, and they were very stable and very good. But at some point, um, they something in this reality changed, and now they need to make a significant change to these applications. The problem is that with these types of legacy applications, it's very hard to understand what specific parts of the application do, how they work, and so on. As I'm sure everyone on this webinar knows, documentation is usually scarce and stale and sometimes just incorrect. And when you need to make a change and you want to make sure that you're making it correctly, that's a big problem. So for many years, a lot of organizations decided to just hold off on making these types of significant changes and particularly modernizing an entire application. However, lately, thanks to developments in AI, it feels like this is possible. Um, the reason is that for the first time, people are seeing that if they go on, let's say, ChatGPT and feed it with a few lines of code, can be Java, can be COBOL, something else, it will tell you what this code does. And this, this is the first time in history that we have a tool that can do that. So you may think that if it can do that, it can take an entire application and just explain what it does, and basically rewrite the specs of the application as it works right now. The thing is that actually understanding a highly complex application is a very, very hard task. And even AI tools, even the most advanced ones, have a hard time to do it. And basically, you're still stuck with this problem of not being able to modernize something that you don't understand. And that's true. It was true for humans, and it's also true for AI systems now. Specifically, lately, some of you may know that Anthropic published a blog post claiming that they can not only understand COBOL, but actually help to modernize it and create a flow that starts from COBOL and ends with microservices Java. Given that, a lot of that made a lot of noise and made some companies lose value in their stock. And we wanted to make an honest effort to see if something very significant changed in our basic assumptions about what AI and specifically LLMs can do. So we took an actual COBOL application, a real life one that's owned by a US government entity and is published. And we ran tests to see how well, in this case, Claude, with the latest models, can understand that COBOL code, assuming that that is a critical step before going through modernization and recreating it in a different language. What we found, and we published this recently, and along with the recording, we'll also send that particular report with all of the information about how we ran the tests. We found several things that basically made us conclude that these basic assumptions we had on LLMs are still true. The first thing that we saw is that there's a ton of the code, and specifically code that includes significant business logic, that was not covered at all by Claude going through the process of trying to understand the application. So, basically it tried to do a third of the job in this case. The second problem, which might even be worse, is that it was highly inaccurate. So 30% of the time, when drawing conclusions about a business logic, which is represented in the code that it was analyzing, it gave wrong results. In some cases, not only wrong, but also misleading. And lastly, because LLMs are in their nature very non-deterministic, everyone here that uses ChatGPT and asked it the same question several times have probably noticed this. We ran Claude code on the same application 3 times and noticed a 42% variance in the number of business rules that it was able to extract and what it wrote about those business rules. Obviously, something that hurts the reliability and trustworthiness of the results. So basically, this means that LLMs on their own are still very far from being a tool that you can utilize for understanding an application and also recreating it, because to recreate it, you need to first go through the process of creating the spec that explains what the application is supposed to do. And particularly with the kinds of clients that we have, like I mentioned, ones from regulated industries with high stakes operational aspects, if you get it wrong, that's not an option, right? So what ends up happening is that subject matter experts that try to utilize these tools end up spending a lot of time going through the results that they got from tools like Claude Code, and it ends up taking them, in the best case, just taking them more time than they would otherwise have to spend going through this process manually, or in the worst case, trusting a particular part of the code, of the explanation that something like Claude provided, while in fact it's wrong, and now they're recreating the application in a wrong way, and that could lead to very significant problems later on. I now want to hand it over to Inbal to talk about Swimm 2.0 and how we are utilizing LLMs, but in a way that maintains reliability, trustworthiness, completeness, and I will let her take it from here and explain how that works.
Thank you, Tom. So Swimm 2.0 is built on this idea that understanding becomes the infrastructure for the entire org to use. We're layering our long existing understanding layer with 2 new concepts we're launching today: our business center, where analysts, architects, and developers can collaborate, and an MCP server that supports AI execution by providing agents with the same Swimm verified context. Before I go into introducing our new concepts, here's a short reminder for the architecture that makes our understanding layer so trustworthy. Our approach is twofold. First, a static analysis engine parses programs, dependencies, data flows, and essentially creates a mathematically accurate mapping of your applications. Since code is deterministic, this step is also 100% deterministic. It is only then that we first introduce LLM into the mix. We're using LLMs for a task they're exceptional at, which is explaining the analysis results in plain language, turning it into specs, diagrams, and business rule tables that both human users and agents can understand. The key here is the order: analysis, then explanations. This is the basic concept behind our understanding layer methodology. Tom mentioned earlier the test we ran for evaluating cloud performance in application understanding. When we compared the results with Swimm platform, the difference is clear. Deterministic context drives complete coverage, perfect accuracy, and zero variance, as the system is grounded in what the code actually does. Okay, so when we were rethinking the modernization challenge, we started from reviewing what organizations have to support this process now, laying out complex application architectures, handling grid-like language, and manually curating business logic by the few subject matter experts that are still around. All that creates bottlenecks and slows modernization decisions. On our core, one of our core, that's fine, click on. One of our core realizations was that this isn't just a developer problem. Understanding is broken along the chain, from business decision makers through architecture managers, all the way to specializing teams of analysts and developers. Swimm 2.0 Business Center brings the process and technical into a shared language that allows to navigate by business function, clear naming, and a complete business rule table. The outcome is faster alignment and real scaling of expert knowledge. We've designed this platform with a built-in trust mechanism. You don't need to take our word for it. Every insight can be traced back to source and verified directly through the code. This traceability matters for reviews, compliance, and for engineering teams who otherwise won't adopt systems that they can't validate. We also realized modernization requires collaboration. Swimm provides a workspace where code, explanations, and decisions stay connected so it doesn't decay or live in silo. Collections are Swimm's reimagined documents. They're allowing stakeholders, whether analysts, architects, or engineers, to curate knowledge for their specific context, augment it with expert insights, and collaborate over it, knowing that everything remains fully connected within your understanding layer source of truth. The second concept we're introducing today is how we go from understanding to execution. The Swimm MCP allows AI agents to consume Swimm verified context directly. When agents share the same verified source your team trusts, you can not only ensure safe modernization, but also move faster with reduced cost, as we established in some recent benchmark tests we've conducted with frameworks such as Cloud Code. The principle is simple. AI can execute the work, but only when the context is verified and consistent that this work is made useful.
So how does this work in practice? Particularly when we work with very large organizations that have dozens or hundreds of applications that are constantly going through a modernization process, right? This year, we're going to modernize these applications. Next year, it's going to be those, and so on. There are so many applications that by the time that we finish with everything, the technology that we started with is, already old, and we need to go through that process again. Another type of organization is global service integrators that are basically doing this for different organizations all the time. In both cases, you need a reproducible factory process of taking an old application and ending up with a new one that is doing the same things, or at least doing the things that you wanted it to do as you're going through this process. These steps are usually what the process looks like. You start with assessment and planning the modernization process. You actually go through extracting the business rules and then plan out what the new specs of the new application need to look like, whether you need to make changes or you want to leave it as it is. you forward engineer using those specs, and then you test and deploy. Um, what we do at Swimm connects with each one of these steps and in a way that is basically scalable and reproducible, even if you're going through several of these in a particular year. In assessment and planning, obviously, because we can show you a top-down view of your different applications and in an application itself, how that application is split up into domains and so on. And Bal is going to show that in a moment. That helps you to understand which parts of the application you have, which ones you want to get started with, how they're connected with each other so that you can plan ahead. Obviously, are where we produce the most direct impact on the process is in the requirement stage, where instead of having to manually go through the excruciating process of extracting the hundreds and thousands of business rules from an application, we do most of that job for the subject matter experts and business analysts that would otherwise need to do that manually, only leaving them some work to add additional context that cannot be inferred from the code. And then, thanks to the MCP slash API that Inbal mentioned previously, and since most of these organizations are already utilizing agentic tools and coding assistance for the forward engineering and building tests and so on, we can also provide all of that additional context about what the application used to do as part of the forward engineering process. So you give a task to something like Cloud Code, reproduce this particular part. If you need to check, exactly what this thing used to do, you can access Swimm and get the specs from there, and get the particular business rules before moving on with the forward engineering task. We are agnostic to the LLM being used, right? We can work with different LLMs. Usually these are LLMs that are already owned and operated and or licensed by the clients, so they were already approved. We're also agnostic to the architecture, where we're installed. We're on-premise, so basically plug and play, so that you can move between projects and still get the same sort of experience that you got in the previous one. I'm going to stop sharing now and let Inbal start sharing a quick demonstration.
Okay. So I'll start with demonstrating the Business Center UI. What we see here is the homepage that you landed on a moment after you've loaded an application onto Swimm. You're encouraged to jump back into work you've started before, but we'll get back to that in a second. You're seeing the application overview, so we can easily see what this application is about at a first glance, right? I inserted, in this case, some small open source application, and I don't really know what it does, but I can see that it implements an insurance back office application. It manages customers and insurance policies, so I get the picture. And then Swimm extracts the business domains from the application. In this case, we get 5. This one seems to have the most processes within. I can see that it's, in fact, the engine that controls the online transaction flows. Clicking into this particular one, we'll see all the processes that Swimm identified within the application and decided that belong to this customer and policy lifecycle management domain. Let's click into one of them. Specifically, the quote calculation seems to be the most interesting one. This is a single calculation flow. It provides a request response for risk scoring. Okay, clear enough. I can look at the graph and it will help me to better understand. I see that the user can ask for a full quote, a risk score, and so forth. And if I want to start exploring this process further, I can go step by step. Let's look at the scoring risk step specifically. Um, this one explains how the service risk score is being derived from two customer inputs, property type and postcode. You'll notice the squiggly lines here. Those are, in fact, indications of glossary terms. The glossary is a central place in which we manage all the business terms that were either generated by Swimm as we analyze the application or provided initially together with the application should you have such glossaries in your possession already. And these glossaries, as I said, they're centrally managed, and your SMEs can edit them, and it will reflect across the application. Let me go back to where we were and continue the flow. Okay, so I understand the two customer inputs. I can also see it in the graph. So this is the graph that describes specifically this step. I know that there's some base risk score and then the first property and some factor that's being added. And then there's the postcode and some factor that's being added. Very cool. I now understand how this calculation works. I can also see it in the form of a business rule. So this is the property and postcode risk adjustments. I can see somewhat a high level description and also all the details of how it's being calculated. I can also see it in the code. This is the exact code snippet that describes the entire risk calculation. I can, if I want, even look at it from the graph view and then go step by step into the code. So this is where the property type is being determined. This is where the factors are being applied, and then go step by step into these calculations and understand how Swimm decided that this is the interesting logic. Let's say that right now my team is looking into this logic of risk calculation, and I'm creating a collection on this topic. And I think that this particular implementation in the code is very interesting and important for my collection. Then I can collect this specific code section. I'll put it here because this is my working document where I'm collecting information about the quote calculation flow. I collected the diagram before, and I now added a snippet. Any artifact from across of Swimm can be added here. When we're first generating the application analysis, we are also generating an application overview as a collection. So you'll find here a full walkthrough of everything that this application has, all the COBOL files and all the structures, and that's fully shareable, and you can collaborate on it, you can edit it, you can add text directly in here. And everything here is being saved. The SME inputs can go in here and they'll be digested and kept together with the knowledge base and besides the code. So far, so good. Let me stop the UI sharing for a second and go into sharing the MCP. So with the MCP, I actually generated this up front because as much fun as it is looking at Claude razzle dazzling, I thought it would be not a great use of our time. So I connected to Claude, and this has my Swimm MCP connected, and I simply asked him using Swimm, take me through the insurance calculation process in the COBOL daemon code base, and then it will go and say high-level workflow, start step by step exploring everything they see from the Swimm artifacts. And let's see. pull in some specific parameters the MCP identifies as relevant for this process. All of this is directly fed from the Swimm knowledge base and curated using Claude. We always encourage prospects and customers to try and test this without Swimm, which we do often to see the differences. It's quite interesting. Another example here is to create a spec in order to modernize this specific menu flow, write a short spec for the Java developers. So again, it went through all the different relevant sections of the code and eventually created an MD file for me. For Java developers, include a suggested controller services repository. So it does the work using all these information from Swimm. Last question I gave is which process used the copybook, the specific copybook name in the code base. And here I got something that no LLM will ever be able to provide, a fully comprehensive, accurate, deterministic, whatever word you want to use, list all the places in which this copybook is being used. Yeah, I think that's it for me right now. Everything we've seen in the UI is accessible through the MCP. Again, the idea is for the AI agents to be able to consume all that context and for it to be the same exact context as the team sees. So it allows for collaboration, humans and agents, and validations. The MCP also has permissions to create collections, so we can collaborate on that as well. If we create the collection that we just saw for modernizing the spec for modernizing the process, this can later on be viewed through the UI and some information can be added by the SMEs. So it's built for that back and forth. I think that's it for me. Are
All
we
right.
ready to go into questions?
I've been answering questions in the Q&A section.
Not nice to answer in private.
No. Everyone can look at the Q&A section and see the answers. I'll repeat one of them. We were asked about a comparison with AWS Transform. So for AWS Transform, basically we see that as a platform that we can get plugged into. AWS Transform also has a documentation feature, as those of you who tried it out know. That documentation feature is primarily based on LLMs and suffers from the same types of problems that we mentioned before for Claude. Differences that in order to avoid too many hallucinations and gaps and the kinds of problems that we showed before, they decided to request that users input file by file in order to get the results. So obviously, going file by file means that you're not overloading the LLM with too much information. You're also not asking it to find or follow flows that are based on elements from different programs, from different copybooks, and so on. So what you get are relatively reliable results on each file separately. The problem with that, as folks put it to us, is that you get 10,000 puzzle pieces that you then need to put together. So if you are a COBOL engineer, you'll probably say, I don't need someone to explain COBOL to me. I understand COBOL, right? So this is not helping me too much. If you are a business analyst and I'm explaining a particular program to you, that's fine. Now I understand this program. But what does this program have to do with the particular business process that I need to understand? That business process likely includes elements of code from across different files. And I, as a business analyst, don't know how to put all those together. So Hopefully, I explained, the limitations of the documentation feature within Transform, and given what we just showed about how we can, you get a top-down view of the application and go through entire processes. You don't even care, particularly as a business analyst, you don't even care where the code came from and whether this process includes code from 15 different programs. What you care about is what's going on, what the application is actually doing. And if you're a developer, you can always click through to see what this generated explanation is based on and trace things down to the code itself. So that relates to AWS Transform. We had a question about Devon and whether we performed a similar benchmarking to Devon as we did for Claude. We haven't yet. But given what we know about Devon and the way that it's structured, it's pretty similar to Claude Code in respect to the advantages and also the problems that we described before. Yeah, and John added here that we particularly did tests with DeepWiki, right? Which is the documentation feature for Devon. The results were even worse than the Claude Code results that I described before in terms of being able to extract and explain full flows across different files and so on. Let's see, open questions, other open questions. Inbal, you can also take a look.
I am.
Yeah, so there's a question here. Is Swimm intended to be used in collaboration with Cloud Code? And if so, what is the best practice workflow for combining them? Inbal, you want to take that?
Sure. As you can see, we also use Swimm together with Cloud Code internally. It's very powerful. We're not competing with Cloud Code in any sort of way. We're the methodology that the infrastructure that allows Cloud Code to be just the tool we need in order to reliably work with AI on code. So in terms of best practice, I think there are multiple answers depending on where you are, in which step you are in the process. So it's kind of hard for me to answer at this time. But yeah, we're definitely encouraging our customers to build agentic workflows on top of Swimm.
So two other questions here. One is about support for other languages. So we focused on mainframe here because this has been our main focus because that is where a lot of our demand came from. Most of what Swimm can do is agnostic to language, and we build what we call a language plugin whenever we need to add support for an additional language. It's very common, specifically with mainframe systems, that they also have open applications that are in Java or C# or .NET. So we support these languages as well. And we can also add support to additional languages in opportunities where it's a very large application and it would make sense to add that. And so it's not a lot of work to do something like that. And then you get all of the algorithms that we already have out of the box after building that particular plugin. Another question here. Let's see.
There is a question
Yeah, price.
on
Yeah, go ahead.
there is a question on essentially unifying logic across multiple applications. So at this time, not yet, but definitely up our sleeves. We're already experimenting with that.
Great. Another question was about the maximum size of code base that we worked with. I believe the biggest code base size of one monolithic application that we ran on was 20 million lines of code. But essentially, there is no hard limit to the size of the code base that we can analyze. It is like the memory of the machine that we're running on. And if If needed, we can shard the work and it just takes longer for the first run of the analysis to happen. And so the reason, by the way, in case you were wondering, is that we're not limited by any context limitations on the LLM side. Because when we run analysis and utilize an LLM, we're basically only sending out to the LLM prompts with very, very small chunks of code to maintain reliability and trustworthiness. So we never really stretch the context window for the LLM. There's another question here about pricing. With whether it's size of the code base or monthly per developer, it's based on the size of the code base measured in lines of code. Let's see other questions. Can we give it multiple repositories and have a single source of truth?
That's what I answered.
Oh yeah, right.
It's definitely built towards that. So
All right. Yes, we do support C#. See. Can it generate test cases? So Swimm will not generate test cases directly, but you can use a tool like Claude Code to generate test cases based on the spec that it can extract from Swimm, either from a report that you created based on the collection feature that Inbal showed before, or just directly through the MCP server.
which is something we've tried in the past. It's a very common use case.
Question here, whether to get pricing, we'll have to submit the source code. You don't have to submit the source code. There's open source, simple open source tools that you can use to count the lines of code. So you can just tell us the lines of code and we'll get back with pricing.
There is a question in here if we see AI agents as the main consumer of the output Swimm produces. So again, I want to remind us that we've launched today two separate concepts. One is the business center, and the other is the MCP server. One is for humans, the other for agents with close collaboration. So definitely you can enjoy all the benefits of Swimm without agents in the picture if you're not using them yet. And you're ready and set to do that as you're ready to start.
Right. There's a question here about how Swimm gets context of the sub-programs or copybooks that may be included in the COBOL code throughout copy. So we parse and analyze the entire code base, including everything, all of the programs, all of the copybooks, all of the calls, all of the dependencies. And before building out these particular flows that all start from some sort of business entry point, we run through all of the processes to make sure that we're including everything and all dependencies that might impact any explanation that we end up creating. And the way that we create explanations is bottom up. So we start by elements that don't call any other elements, understand what they do, and only then go up a level and see an element that calls other elements using whatever we understood about those elements to gain an understanding about that element that calls others, right? Moving up the tree that way. So that would include, for instance, any relevant information in copybooks that we need in order to understand what's going on in programs.
That, by the way, brings us to two different and interesting cases. One is identifying code that we don't have in the file that you've uploaded into Swimm, but the code that you did upload refers to in some way. So we'll be able to tell you what's missing, which is very common when using Swimm, and users are uploading files that they don't really know in depth. And the other is identification of code that's not being called anywhere, so essentially dead code. Yeah.
All right. I saw a couple of questions that asked about various things that you might be able to do with the um, raw mapping of the code itself. For instance, looking for different elements that are similar in various ways. One of the ideas behind the MCP server, as opposed to the user interface, which is based on a particular experience that we built out for
An exploration experience.
exploration experience, right? For business analysts or for subject matter experts that want to verify things. The MCP server is meant to be relevant for any use case that you can then utilize through a coding assistant or an agentic framework. So any type of analysis that you want to run that utilizes an agent to go through a lot of things and test them to check for similarities, to check to find a specific element and so on, you can do. And there's a lot of artifacts that you can get through the MCP server that are not available in the user interface. Anything that relates to forward engineering and further analysis of the code is not something that we would do directly or contain that within a feature within Swimm. Rather, something that we would want tools that specialize in it or general tools like coding assistants to be able to get the right information from Swimm when doing that. I think the last question here about utilizing Swimm for during development um, to for guidance. Same as what I said before. Anything that relates to forward engineering is something that we see ourselves as a knowledge base or a context layer for any agent that needs that accurate and complete context in order to perform a task, and that task can be analysis as well. Since we're out of time, we're going to end here. As mentioned, this was recorded, so we're going to send out the recording along with the full report of our comparison with Claude Code. And we hope to be in touch in the future if you're interested into looking into Swimm for your company's needs. So thank you, everyone, for joining today, and thanks as
Thank
well.
you.
Bye, everyone.
Bye.